Okay, good afternoon, everyone. For those of you who don't know me, my name is Gianluca Baio, and I'm the head of statistical science, and I will take all the credit for the fantastic day, although I haven't done anything whatsoever apart from showing up right now. And actually, Peter and Eleanor should deserve all the credit because they have made today happen. And I think I'm gonna take just 2 minutes of your time. And if you know me, you probably know that for me, statistics is a big thing, and it should literally be in charge of everything. So I think today is one of those good days where we can try and be in charge of everything and tell people how to teach statistics. Thanks to Andrew. And I guess for normal people, this should feel like when they go and meet their favorite footballer or something, right? So we're all very excited to have you here, Andrew. And I should also mention very quickly that this is kind of a joint effort of NASH, the UCL Network of Applied Statisticians in Health, of which Peter is a representative, our department, Stat Science, of which Eleanor is a representative, and the wider HAT IMSS, the Institute of Mathematical and Statistical Science, which is kind of trying to make sure that at UCL and beyond, stats and maths are at the very center of everything that we do, because I think it's a good thing to have. And I think I'll leave it with Peter with a few announcements for housekeeping, and then he'll introduce Andrew. Thank you.
Right, thanks. I feel some credit for making this happen should go to Andrew, but we'll see. Thanks for the introduction, Gianluca. So welcome everyone in the room, and also welcome everyone online. A special shout out to the Burwells Conference of Statistics Education, which is happening in Belfast this week, and who have interrupted their program to join us online. So special welcome to you. What we'll do is Professor Gelman will talk for about 45 minutes, give or take. And then there'll be some time for questions. We'll have roving microphones in the room. But there's also, if you're online or if you prefer to ask your question anonymously by typing it, you can also log into the Slido website, and the code is displayed up here on the slide. If you're online and you can't see that slide, if you look at the description of your YouTube video, you can anyway find the code and so the information how to ask a question online. If you're here in the room after the talk, there'll be a drinks reception, which is at the UCL main campus, to which you're all warmly invited, and we'll display directions on how to get there after Andrew's talk. Well, we don't expect a fire drill. We don't expect a fire either. But if there is an alarm, we do actually need to leave. So the fire exits are the doors through which you came, behind you, or this door. But not the other side. So this is a fire exit and up there. And then finally, it's you probably don't need an introduction to the speaker, but it's customary to do so. So I'll do a very brief one. So Andrew Gelman is Professor of Statistics and Political Science at Columbia University. He's won numerous awards, including 3 times the awards for the Outstanding Statistical Application from the American Statistical Association and many others. He's the author of several books, including Teaching Statistics, a Bag of Tricks, Bayesian Data Analysis, and Regression and Other Stories. And he told us today that 2 more books are about to be finished or are finished and will very soon come out. So we're very honored to have him here today. And we look forward to the talk. So please join me in welcoming Andrew Gelman.
So I'm gonna do a couple things today that I don't do that I think we should all do when we teach, and I'm not doing. So I'm gonna violate 2 of my teaching principles. So maybe you can ask me afterward what those 2 principles were that I violated. I want to start with a couple stories. I was contacted a few years ago by some people from the Wikimedia Foundation. So they're the people who raise money for Wikipedia with that nag screen that says that nobody gives money, but if you would give £2, that would be very helpful. They do they do a lot of A/B testing where they randomly try 2 different things to see which gets more donations. It seems like a lot of trouble, but it's not. It's actually free to do A/B testing because you're already randomly giving people the NAG screen. So then you can randomly give different NAG screens. And they had lots of stories about this. Apparently there were some so-called behavioral economists who were complaining that they said that they should do their requests differently because they say nobody contributes, not many people do. If only a few would, it would really help. And the behavioral economist said, no, you're supposed to establish a norm of consent. So you should actually say everybody does it, and you should do it too. And so they tried an experiment where they changed the NAG screen to that phrasing, and it didn't help any. And that's selection bias. I like that story because it makes the economists look bad. And so that's just one data point for you. They contacted me because they said they're doing a lot of experiments, and sometimes they would get null effects, but sometimes they would get these very large estimated effects that were implausibly large. And they knew that I had done research on implausibly large effects, and so they wanted to know what I thought. So I said, send me an example. So they showed me an example. There was 2 versions of the NAG screen. One had round corners, the other had square corners. This is the silliest thing in the world, but again, try everything, why not, right? So they found that the square corner treatment reduced the rate of contribution by 15%. It went down from like 0.5% to 0.43%. That's like first 0.5% contribution isn't bad already, but anyway, going down by 15% is a lot. Well, let's see, it was statistically significant. No, it was like 10 standard errors away from 0. And out in the like post-Galton zone, as we like to say. And there's no way, like, you wouldn't see that by chance. It's not selection bias. It's not reporting bias. Like if you see something that big. So I said, well, what's going on? You see an effect of 15% reduced contribution, but that was just one day you did your experiment. Maybe you do it one day, and then at night, maybe the contribution, maybe it helps. Maybe it goes up by 20% the next day and down, and so like maybe it's a large effect, but not a true large average effect, right? Just something you saw one day. And they said, well, they didn't believe that. They didn't think that was what was going on because they found that contribution rates varied a lot. They were tended to be higher in the day and lower in the evening, but they did not tend to find treatment effects varying by very much by time. So they were suspicious of that explanation. So then I looked at the report. This was like one page of their summaries, and I noticed something that looked kind of weird because they had the number of cases. It was like 1 million people got one screen and 1 million got the other. But it wasn't 1 million. It was like 925,000 got one of them, and it was like 1.1 million got the other. It wasn't 50-50. And it was like the numbers were big enough. It should have been really close to 50-50, and it wasn't 2-to-1. So I said, is it supposed to be 50-50? And they're like, yeah. So why is it? Let's look. So they had it was done over a 12-hour period. For every minute, they had the number of people who got the treatment and the number who got the control. And we made a graph, and it was very equal. It started at 4 p.m. Then about 8 p.m., it diverged. And after that, like a lot more people are getting the treatment. They're getting the control. I don't know why. Like, nobody knows why. Nobody cares why. I mean, maybe they should, because maybe somehow they were either not giving it equally to the two groups, or maybe they weren't recording it right. And so that was an imbalance. And the imbalance, and remember I told you that contribution rates are different at night than in the day. So that was a little foreshadowing, as we'd say in English class back in high school, that it made a difference because the treatment was done more. The control was done more in the early hours, and the treatment was done more in the late hours. So contribution rates went down. Okay, what's the story of that story? I'll tell you another story first before telling you. So the other story, this is very popular in USA statistics textbooks back in the day. Maybe they still use it. It was a survey done by a magazine called the Literary Digest in 1936. It was a U.S. presidential election where Franklin Roosevelt was running for re-election. He won by a landslide with 60% of the vote. But there was this poll that was done, and in the poll, he was going to lose, like by a lot. And it was a big poll. It was a survey, it was a mail survey. It was sent out to 10 million people, and 2.5 million people returned them. And of the 2.5 million people, like well over 50% were supporting the other candidate. So at the time, it was a big deal. Afterwards, it's been very popular in statistics textbooks because it's an example. It wasn't a random sample. It was just, they sent it to everybody they could find. It was actually a lot of pretty well-off people because of mail survey, and they used things like lists of people who own telephones and people who own cars and other people who were richer than average. And then a lot of people didn't respond. So it's always used as an example of how if you don't do a random sample, that's the Literary Digest was considered the dinosaur of polls. And then the scrappy little mammal, the Gallup poll, they just did a survey of 1,500 people or whatever it was, some small number, but it was supposed to be a representative sample, and they got it right. So they always put this in the statistics books. It's kind of a weird example, though. For one thing, the Gallup poll wasn't a random sample either. They used quota sampling. They tried to be representative. But something I didn't know about, but a couple statisticians, Michael Brick and Sharon Lohr, wrote about this a couple years ago. They went back to the original Literary Digest poll, and there was a question on this very short survey. It wasn't even a survey. It was like a little thing you get in the mail and send back, like 5 questions, 4 questions maybe. One of the questions was, who did you vote for in the last election? And they looked at the data, and they found that if you look and use that poll to predict the last election, it way underestimated the support for Franklin Roosevelt. Like it was biased, and so you could correct for that bias. You could adjust for that. Now, what's the point of these 2 stories is that in introductory statistics, we love telling stories where people have a biased study. They don't do the randomized experiment, and then they're biased. They get the wrong answer, and so we say you should randomize. Blah, blah, blah. Or it's a survey, it gives the wrong answer. Oh, you should do a random sample. It's kind of weird, though, because like in real life, our random sample surveys are not really random samples because most people don't respond. And also our real life experiments are often not balanced because there's some problem. The Wikipedia is an extreme example of that. Right? So, but you can correct, you can see problems in the data and adjust. So the idea of going further, right, is saying, yeah, random sampling, experimentation is great. It's a great principle, but then we can do some adjustment. Or even if we didn't do that, we can do some adjustment. So statistics about design and also about adjustment. And now, there's a challenge when we teach, right? And one of the challenges of teaching, there's a balance between the simplicity and complexity. So we have a tendency to like to tell more complicated stories because we've heard all the simple stories already. But when we teach, we need to teach the simple stories. So the idea is you do the simple example, and you do that a few times until the student can do it, and then you do the more complicated thing. But it's a challenge. Because the example shouldn't be too simple, or I think you're sending the wrong message. So what are the components of a statistics class? What is statistics teaching all about? What is teaching all about? I think there's 2 reasons why we're teaching. I mean, there's a goal, obviously, right? The goal is that the students can be able to do certain things right away, but then probably more importantly, the goal is that when the students become larger, fully formed people, no longer tadpoles, but actually frogs jumping around, that they have the tools so that they can solve problems. Of course, they already have the tool. They already can Google things, but they can't, or even find textbooks, but they can't necessarily make sense of it. So we want to give them a lot of practice. But there's really 2 things. And one is we want to motivate the students to learn, and the other is that we want to give them good stuff to learn. And I like the analogy to physical therapy. So if you go to your physical therapist, there's the number one thing, the number one skill of a physical therapist is being able to motivate you to do your homework, to do your physical therapy. There's only a limit to how much you're going to get better in those 45 minutes in the office. That's number one, but a very close number 2 is that she should give you the right exercises, right? It doesn't matter if you're very disciplined if you're doing the wrong thing. You could be hurting yourself. So we have that, the twin aspects. It's motivation and content. Now, let me step back and kind of do an intersection between how the wrong things that we teach in statistics classes and education research and how we can do better. So the model, the way causal inference is typically presented in statistics books, including, I regret to say, a lot of what I do is what we call the take a pill, push a button model of science. I remember when I first took an applied statistics class in grad school, the teacher told me, he said, this is really cool. You can prove that something works without knowing how it works, like a randomized experiment. And it's true, you can. It just doesn't happen that way very often, because where did you get the treatment that works if you had no idea how it worked? Right? So there's a paradigm, I sometimes call it the penicillin paradigm of science, which is that you discover something and then you test it. That doesn't describe most of what we do. Consider education, how that's different. So one thing is that education is not suddenly curing a disease, the disease of ignorance. Rather, it's incremental improvements, right? People are already trying their best. It's like economics, right? Like that people are already trying their best, so you're getting marginal improvement. Not only that, but good ideas can sneak through the back door and end up in the control group, right? It's not like the drug, it's not like there's this new teaching method which hasn't been approved yet by the Food and Drug Administration, and so like, yeah, it can't be done. Like any good teaching idea, people are possibly already doing. Also, a very important thing, again, like physical therapy, physical therapist doesn't give you a pill to take, right? I mean, that's what doctors do. That's why we go to physical therapists, because they do something different, right? And they're not usually giving you a preset set of exercises. They're working with you. And with the teaching, there's the interaction between teacher and student that's so important, right? Then this idea that motivation is what's most important, but we're not directly measuring motivation. Most of teaching is teaching motivation, and yet it's not something we measure. So we are not measuring the outcome of interest. It becomes particularly challenging. No, I don't have an answer to this at all. I don't say, the title of my talk is not a new paradigm for evaluating education research. I don't have a way. I don't know. We're doing, like, this is really crude what we're doing. We're just trying stuff. But I think we should recognize that, right? And it could affect how we teach causal inference, especially when we think that education is the most familiar example for students. I find, what examples are students interested in? A lot of students like sports. A lot don't. It's not always the best example. It's one of many examples. Health, students are mostly not interested in healthcare because they're mostly young and they're planning to live forever. Relationships, friendships, family, everyone's interested in that, right? Like everybody hates their parents, right? But I think it's a little too close to home. Students seem to find it uncomfortable. When we give students projects to work on, like, hey, gather some data, do whatever you want, they do these stupid things. Like, oh yeah, we did a survey. We asked each student like how many hours of sleep they took each night and what their grade point average was. And, they're doing extracurricular, whatever, stuff like that. I went out in the street, I counted how many cars there were on each day. So, okay, at least they're thinking about measurement. That's fine. But I think when I've talked to them, what examples really grab them are education. Oh, that's interesting, but it's also interesting that it doesn't fit the paradigm. One of my pet peeves is social science statistics classes where they keep bringing up medical examples. Like, here's the treatment and the control. You take a pill, like, how long do you get? Well, if that's, like, it can't be right? Like, you should be proud of what we do. If I'm a political scientist, I'll talk about getting out the vote, right? Let's do an experiment on getting out the vote. Or let's look at the effect of learning on politicians of learning about public opinion. Does that change how they're going to vote? Like, whatever. Things that really matter. I mean, medicine's important too, but that shouldn't be the examples that I give if that's not what I do. I think that's a real problem. So, okay, as I keep kind of emphasizing, it's all about form and content, right? I'm not going to talk so much about content today. I talked a little bit. I have very strong feelings about that. There's really only one introductory statistics book, period in the world that I currently like, that has content that I like. All the others I dislike, even the ones written by my friends, even the ones that are very friendly and well written, I hate them all. There's only one. I like my books, but more advanced books, but at the introductory level, there's only one I like. And I think content's an issue, but I want to talk about form today. So content is, again, like what we want people to learn, what we're teaching them. That's obviously super important. Form is motivation. It's what do we do to motivate people to teach themselves, which I think is what teaching is, at least for me. So what do we do? Well, in class, I tell stories. I do class participation activities. We have discussions. I do hands-on computer demonstrations. I write drills on the blackboard and have students do quick problems. I have longer problems that then they can work on in pairs or small groups for 10 or 15 minutes. Well, each class is 75 minutes. I don't always have time for all of those in each class, but I try, actually. People have said things to me like, I love your bag of tricks book. I did one of your examples. Like, no, like every class. I do this. So I decide, last time I taught out of regression and other stories, I said, okay, this is it. Okay, I am going to write it all down, what I'm doing. Because I would tell stories, and the stories were great, except I'd come up with them in the middle of class. I had no idea what the story was going to be about. Someone asked a question, it would remind me of a story, and I would tell it. So it wasn't like, then I had to remember how it was related to what was in the class ahead of time. Also, it's not so good for other people to say, just tell stories whenever you feel like it. Sometimes you're getting the wrong message. What they're remembering isn't the right part. So I thought, I got to write these down. Class participation activities, every class. So I really like this. I'm always having students work in pairs. So I always have them discuss stuff in pairs. When we have a question, I won't stop and say, any questions? I'll say, okay, everybody talk in pairs for 45 seconds and discuss. And then there will be questions, right? That's good, right? Because people can learn from each other. Best way of learning is teaching. Also keeps them alert. Often they're not, like they're sitting there doing something else. So I look them in the eye. Not easy for me personally to do. I don't naturally look people in the eye, but I'll do it. I look them in the eye, I go like this. And then if necessary, I walk up and I say, like, excuse me, could you turn off your goddamn phone, please? Thank you. You know, all right. No, in a polite way, like I'll talk to them after class. But like I'll go, you know, that makes a difference. Right? So the activities though, okay, we have a few things in our bag of tricks. I wanted 52 activities. Because I teach 2 semesters, 13 weeks, 2 classes a week, that's 52, right? So applied regression and causal inference. I'll get back to the activities, but their class participation, super important. The discussion is, I have a Google Doc, and every student's required to put in something before each class in the Google Doc, either a question about something that's confusing about homework or the reading, or answering somebody else's question. That gives us material. Then I can answer some questions in the Google Doc. Then I do an online hands-on demo. The computer demo, it's great. So I have the computer on, right? It's sitting there. It's saying I have R. Sorry, I use R. I apologize. And I do it from scratch. I type in the code. Well, I have 2 windows, right? So there's the text window, and then there's the command window. So you don't type directly into the control window. That's not good, right? So you type in the text editor. I type in the code, then I copy and paste it. I don't copy and paste. I type it in. When I type it in, it's like, could be happening. They could be doing it. Then later they can get the code, but I'm typing it, I'm reading it a lot. Oh yeah, here I'm making a plot. You see, like plot X, Y, like X is the X axis, Y is the Y axis. I can say it while I'm typing, but it's all done ahead of time. I found that students love these live demos. This is their favorite thing, but I would often just wing it, and then it didn't always work. And like you do it ahead of time. You spend an hour ahead of time for that 15-minute demo. Well, you don't need to spend an hour ahead of time because I put them in our new book, right? Active Statistics. So you have them all. We put them all in. But I realized when I did it ahead of time, then I set it up, then it worked. There's actually some interesting statistics on how to set up a demonstration, because a lot of the time, sometimes I use data that we collected in class in the activity. Other times I download data, but a lot of times I simulate data. like simulating experimentation. It's really great. You know the answer, you could check. I think that's an important skill for the students to have. Then we have the drills, little questions, longer problems, things that didn't make them into, weren't quite stories, but they're good, fun little problems. That can be good too. Outside of class, we have homework, we have the textbook to read, and we have exams. I think it's very important to me. I don't like to, everything I'm teaching should be on the exam. So I want them to be able to do simulated data experimentation. So I have some exam questions on that. I wrote multiple choice exam questions. So we'll be like, here are 4 different sets of code which are supposed to simulate linear regression, where there's, here's the true intercept and slope, and you simulate data, and then you check the coverage of the t-interval. Which of these 4 works and does that? Like things like that. Like they're not necessarily the hardest thing, but it's important to know ahead of time. I wrote a bunch of exam questions ahead of time. So for each week of class, I wrote 4 or more questions. Then I take a random sample of them, and that's the final. I take another random sample and give them to them, and that's the practice final. I'm lazy, so I sample with replacement. They might get the same question twice. That's okay, right? That motivates them a little bit. So these things go, the 2 aspects of the class go back and forth, right? So the exam motivates the other parts. I want to give you some examples. I've given you a couple of stories, so now I'll give you some, and I'm not going to give you examples of the hands-on. Well, I might do the computer demo too. I'm not going to do a computer demo. I'm not going to do anything for you. I'm not actually going to do the activity. I was thinking of coming in and doing activities for you all, but I thought I'd describe them instead. My favorite ever is the candy weighing example. So here I have a bag of candies. I go to the store and I get 100 candies, and they're like about 20 big candy bars, and then about like maybe 30 small little bite-sized ones that you would have like the miniature candy bars that might be on a dish somewhere, and then 50 really small like single things like single lifesavers that are pre-wrapped, or little tiny very light pieces of candy. So I take the 100 candies and I put them in a bag, opaque bag, and I have a kitchen scale, and I give it. I go to the front of the class. I hear what I'm going to do. I want each of you to, in pairs, to estimate the weight of the candies in the bag. But you're not allowed to put the candy in. You're not allowed to weigh the bag of candies, right? That's cheating. So I have this thing. The first step: take 5 candies out of the bag. Second, weigh the 5 candies. Third, take the 5 candies, write the weight down. Fourth, put the candies back in the bag. Fifth, pass the bag and the scale to the next people. Last step, take the number you have and multiply it by 20. Now, I have that on the screen, projected, or I write it on the blackboard. Super important with class participation activities. You have to write the instructions down, because otherwise somebody misses something and they're stuck and they can't do it, right? And you don't get credit. Like, I tried, they weren't paying attention. It doesn't work that way, right? You're trying to motivate them, right? That's your job. You're getting paid, right? So then I pass it to the first pair, and they do that. Oh, and then the last thing is write down your number after you multiply by 20. So they go around the room and do it, and everyone's doing that, getting a sample of size 5. I say take whatever sample size 5 you want, but your final number, which you have to get by taking your weight and multiplying it by 20, whoever gets closest gets the whole bag of candy. I did this with 5th graders, and the teacher's like, no, it's going to get shared. Okay, so then you just get pride. Okay, just that. So we do that. So time is important, right? So meanwhile, then we teach a class. We're teaching something in class. Like we might be teaching sampling or whatever we're teaching. So we're doing our class. We're doing stuff. Maybe in the meantime doing a discussion of the homework, hands-on computer demonstration. It's gradually going around. This particular demo takes a while. And then maybe after 20 minutes, the people in the back are done. Right? So then they bring it there. I say, well, let's everybody tell me your weight. Tell me your estimate. So they tell me, and I write them down on the board. And we can make a little histogram if we want, like just a little sense. You get a sense of these things. And then I say, well, just, like you seeing what everybody else did, like you might want to reconsider your estimate, feel free to do this. So we're going to go for this. And I say, this is like a sampling problem, right? Each pair was a different sample. Some of you might have had the same sample, maybe not. So this is called the sampling distribution. So it really like comes to life. Like, what's the sampling distribution? We talk about, well, is this a biased estimate? We can see the variance of the sampling distribution. What's the bias? We need to know the true value. And so I say, okay, let's weigh it. So I have some student in the front weigh it, and it's much lighter than almost all their estimates. Like usually there might be only one group that has an estimate that's close. Because when you grab 5, you grab the big ones. Actually, even in terms of physics, the big ones float to the top because the little ones fall through holes. It's very hard to not do. Then it'd say, like, look, you have estimates. Like a typical estimate would be like 1.5 kilograms. Like, so they're getting the true value might be 1.5 kilograms. They're getting estimates like 4 kilograms, and then I make fun of them a little bit. Like, you thought this was 4 kilograms of candy? Like, what the hell were you thinking? Well, it's easier to do this in the US because people don't know what a kilogram is. Say, can you do me a favor? I point to someone in the back and say, isn't there something? And there's like a back behind like the window, there's an envelope. Can you open the envelope? They open. What does it say? And it says, your guesses are too high. And like, how did I know they were too high? So I already told you, but then we have a discussion about this. How does this apply? How does this principle apply in other settings? So you think about different ways to go. How does this apply in other problems other than weighing candies? Right? Also, how would you do better? So people talk about that. Like, you could do a stratified sample. Like, how do you do a stratified sample? You need to know something about the population. Right? So that's an interesting thing. When people talk about sampling, they don't think enough about the population. They just think about the procedure of random sampling. But to do a good job, you need to know something about that. Now, depending on the class, we can have more discussion about this. The point is not to have I have stories about sampling, but the point is not to throw every story I have about sampling in. The point here at the end of the example is to loop back and very explicitly ground it in what was being taught that week, which might have been the sampling distribution, or it might be random sampling, or it might be the concept of bias. Like, whatever it is, you have to make that connection. And that was one reason why I felt it was helpful to write these activities down. So that was one, and that was somehow loosely adapted. There are existing activities people have with sampling, but they're all lame. They're all really bad, right? So there's this thing, a classic thing people have, like the candy of the different colors. Like, what percentage of the M&Ms are blue? And there's 100. People grab a sample of 10, and here's the standard error. It's like, who cares, right? And it's just like, that's just stupid. Like, what percent are blue, right? This is more interesting. It's this bias which you can connect directly to real surveys. So this relates also to the idea that we want our activities to be connected to the course material, also connected to the real world. They should also involve active participation of the students. So they're not just that they're doing stuff, right? They're not just blindly sampling, they're thinking. They're thinking, because I want to win, right? I want to get a good sample of 5. It really, to lose after you've been trying to win, that makes a difference. So it's not like class participation. The same with surveys. Sometimes we do this in class where we have students ask questions. We do a little survey in class. So, but you can learn some stuff there too, like predicting issue attitudes. So what's a good way to predict people's issue attitudes? You can gather data in class and find that often the predictors they think are good aren't so good. So they've actually learned you can't learn that much from a sample of size 50 unless you have very good measurements. Right? So this is like, it's super important that the measurements be like relevant to the real world. Also, you need to have some control. This is why people, I think, often don't do these activities, because you feel like you lose control. So by trying to set these up, I did that. Now here's another example, another activity, which I'm really proud of, which is the 2 truths and a lie game. So there's there's a game you can play. It's an icebreaker you may have heard of called Two Truths and a Lie. So you pick someone and she says 3 things about herself, and then everybody else has to guess which of those 3 is a lie. Right? So and then it's like, haha, no, I'm not adopted, whatever it is, right? Like that's the whole thing. And it's a great way, so I was using this in the first class of the second semester because you get a lot of new students, so it's an icebreaker. But what we did was put the students in groups of 4. Now again, we have the instructions here. Get in a group of 4, right? Choose one person as the storyteller, okay? She tells 3 statements. The other people then discuss which of the 3 they think is the lie. They come up with a consensus. And then they also come up with a certainty score between 0 and 10. 0 means I have no idea, 10 means you're sure. And then the storyteller reveals whether the guess was right. Then rotate. So if you have 4 people in the group, you get 4 data points. And that's all up there. It's tricky, right, to remember, but it's not hard if you're doing that. So they do that in groups of 4, and they get to meet each other, and it's fun. Then we have the data. What do we do with the data? Well, I don't write it on the board. Use a Google Doc. So I created a Google Doc ahead of time. I give them the URL. They pull out their phones, and they put in one person from each group enters the 4 data points, which is their 1 or 0, like correct or false, 1 or 0, whether they got it right, and their certainty score. And then we can, what you're doing depends on the class. You could do multi-level modeling with that. I wasn't teaching multi-level modeling. No, I was teaching, it was the first week of the second semester, or the second week, whatever, I was doing logistic regression. So we did logistic regression, predict probability of correct based on the certainty score. But here's a fun thing you do. Before doing that, what we're going to do, here's the R code. We load it in. I do everything, but I don't fit the model. I don't type return. And say, what are we going to get? We're going to get, what do you think this coefficient's going to be? The intercept and the slope. How do you think about what an intercept and the slope is going to be of logistic regression, right? You have to think about what that even means, right? So the intercept would be the probability of getting it correct if your certainty score is 0. The slope would be if you multiply it by 10, it's how much the logistic probability changes going from, and is the slope going to be positive or negative? Do you think it's going to be statistically significant? So they can write their graphs. So I go around the room looking at what they did. Say, oh wait, is this curve consistent with your thing? We do an example, given the numbers, what would the curve be? This could go on you could do a lot on this or a little, right? Then you reveal the result. You can see how well the certainty score predicts, see how accurate people are. So you step back, right? Before you gather the data. This is good scientific practice. We don't always, statistics are start with the data. Here's the result, then explain it. I'm a social scientist. I used to do that all the time. I try not to do that anymore. Right? You try to anticipate the data. What would you say? What do you think? How low could the success rate be? Could it be less than 33%? It's possible, right? Could it be, how high, how accurate do you think people are? The actual thing, I think half the guesses roughly were accurate, and there was no relationship with certainty score, right? But we didn't know that. So make some predictions, right? Then, okay. So I'm really proud of that because I had 2 goals here. One was I wanted an activity for every class, a true class participation. I'm telling you, these are some of the best activities. Some of the other activities are a little more boring, I admit, but I want one for every class, and the second thing was, I thought 2 truths and a lie would be fun. So I am so proud of myself because I charted it. I was like, we're starting with 2 truths and a lie. I want to make that into an activity. How can I do that? Okay, think about that. But that was good for me to think about what is the statistical content there? What does it mean to guess? How accurate is it? There's a lot of good stuff, right? A lot of things that you can do. And even simpler things. We have one activity where I'll give you a more boring one to say. We have students measure handedness. Left-handed, how do you measure that? So there's a standard handedness questionnaire. It has 10 questions. Some of the questions are inappropriate for students. No, it's not what you think. It's some of the questions are inappropriate, meaning they don't know anything about this. Which hand do you hold higher when you're sweeping with a broom? Well, do our students sweep with a broom? No, right? So certain things like that, or things that might depend on your culture. But there are we use 6 questions, like throwing and catching and writing and a couple of other things. So we have them fill out the form, and you're left-handed or right-handed or both or in between. You create a score, which goes from -1 if you're all left to +1 if you're all right. Again, we have it all on the board. And then, but we have them fill out the form, and then we ask them to sketch the distribution that they think is the distribution of the class. And then we display the actual distribution using, the Google form. The actual distribution tends to be much more continuous. First, there's a lot fewer left-handers than people think. And the second thing is that it's not a bimodal distribution of left-handers and right-handers. It's a lot of right-handers and then a sort of long tail out here. Lefties are less, have weaker hand preferences than righties. You get a lot of mixed people. Again, brings a histogram to life, whatever. It's but you gotta, when you're teaching this, you gotta think about what you want to teach. Personally, I don't give a damn about histograms. I don't really talk about that. But I use this as an example of measurement. So I'd say, you can learn from measurement. It's not even clear what it means. Like you might say, are you a lefty or a righty? That's a question. But actually, there's a latent thing you're trying to measure that you can only get from multiple measures. And again, if that's your issue, you can talk more. You can talk about depression inventories and like terrible things they do. Like in a more advanced class, you can talk about they'll do the depression inventory, and if your score is less than 6, you're depressed. Like what if you're 7? Like, congratulations, right? Often that's driven by bad statistical methods. Let me say one more thing. I guess then my 45 minutes of fame are over here. That I'll give you an example of one computer hands-on demonstration. I do a lot of these simulations, pre-test, post-test. You can teach linear regression, logistic, regression to the mean, graphics, right? Sometimes a demo will just be how to make some graphs. I like to simulate the data. So let's say I want to have that pre-test, post-test. I'm going to do a regression. I'm going to do, like, my go-to example is treatment control, pre-test, post-test. Right? So I have treated units, control units. Each one has a pre and a post. And you make a scatter plot of post-test versus pre-step. We have so many examples of this in regression and other stories. This is, to me, very fundamental applied regression causal inference model. I use 2 colored dots, like blue dots for the controls and red dots for the treated. So early on, we do example of that. You can use real data. So we're doing simulated data. The treatment's going to have a pretty large effect because I want to make it clear. There's going to be a certain amount of variation. How do you simulate the data? Well, I could simulate the data by saying, well, there's a pretest score, and they're kind of, the pretest is on a 0 to 50 scale maybe, and maybe I'll make it like uniformly distributed, or maybe normally distributed with mean 30 and standard deviation 10, and then the post-test is, well, they could go from 0 to 100, so I could draw a linear regression, although that's not a very generative model. So sometimes I'll make a generative model, and I'll say, you have a true ability, and the ability is normally distributed with mean 0 and standard deviation 1. Then the pretest score is scaled so that your pretest score is 30 plus your true ability, 30 plus 10 times your true ability with a certain error attached to it because it's measured with error. And then your post-test is something else, and but then your ability has gone up from pretest to post-test. So that goes up. And then also there's another independent error term. Then you get correlation. It induces correlation because there's variation in ability. But that's like, it's not so easy to construct that. That's the kind of thing you really do have to first play around with at home and get the numbers to make the graphs kind of look right. Then depending on the class, you might open that up a little and talk about that. Or you have students work together and say, well, come up with a simulation of your own. You want to involve them as much as possible. So what I've tried, this is the end of what I have for you today. I mean, I had more material planned, but I didn't use it all. That there is this balance that you want to make things clear and illustrate the topic, but it should also be relevant to the real world, which means real world complexity. And I think that's very important at least to me when I teach, that's a big motivator. to say, we want you to learn these skills, but these skills are not the end of the line. That a random sample is neither necessary nor sufficient to learning about the population of interest. And a controlled experiment is neither necessary nor sufficient to learn about causal inference. But if you learn these things, then this might reduce some of the burden on the adjustment. And some of this can be done if you're teaching regression anyway in your class, then you can do that. And I do think it's possible. It took a lot of work on my part. I needed to do that because otherwise my students would stare into space and they weren't learning much in class, I don't think. So I did all these things in order to keep them, in order to motivate them and to make the actual classroom period useful to them. Probably more important than ever now with the modern world where people are online and so forth. You can make it like 75 minutes of excitement every time. And so you just like, you can't wait to come back to class to do these. So I hope this has motivated you to do some of the same.
Well, can you hear me on the microphone? Yeah. Well, thanks, Andrew. That was great. It certainly motivated me. Are there any questions either in the room or on Slido? If there are, we have roving mics here, which I'll just distribute. And the first person that I saw was in the second row, the gentleman.
Thanks. Thanks, Andrew. Really fantastic and motivating talk. You touched at a few points on the importance of looking at context and relevance of that context. Can you just say a little bit more about how you choose those contexts? So do you choose things that you find interesting, what your students find interesting, or what you think your students find interesting? Or how do you go about doing that?
So I guess first, let me say that I'm not doing any of this systematically. So I'm violating like basic principles of statistics. So principles, like if you want to do something effective, what you're supposed to, well, let's say, I'll do a randomized experiment. Well, you have to step back. No, do a controlled experiment. That's okay. Well, let's step back a little more. You have to define a treatment and a control, which I haven't done. Like I'm just trying stuff. What else? Oh, well, you have to define a population, a target population. I'm not doing that. Like it's not just that I'm not randomly sampling who gets my thing. It's whoever shows up, right? I'm just trying things every semester. So even if I had the assigned treatment, I'm not assigning it. I'm not measuring an outcome. I have a final exam that I wrote, which is not much of an outcome. I don't always have good pretest measurements, which I've already said are essential. So my answer to that is I think we're in the pre-modern or pre-scientific or pre-statistical world in statistics and teaching. And a lot of, not all education. Education research is a lot of great stuff, but where we are in statistics education research is pretty much at the pre-scientific level. For me, it works best when I teach applied statistics to the political. You'll get to ask a question. So to me, like I get to teach applied statistics to political science students, so they're interested in political science. So I do a lot of political science examples. Otherwise, it's stuff that I care about or I think they care about. That it's when you gather data from them, it's a balance because you want it to be interesting, but you don't want it to be embarrassing, right? But things like political attitudes and stuff, I could do some of that. I have some sense of what they care about. It's certainly not just what they care about. It's a lot of what I find interesting, but it has to be. I mean, it's seen stuff like the active statistics. I mean, the statistics teaching literature. It's full of weird, oh yeah, we have a random sample problem with rectangles. You cut out little rectangles and then you sample the rectangles, and you're more likely to pick the big ones. Well, obviously, a bag of candies is a little bit more vivid. I think one comparison is to physics teaching. Physics is much more codified. The physics teachers have a lot more, like a lot of my ideas I stole from the physics teaching literature. They have a lot of active learning. They're much better. It's much easier for them because they already know what they're going to teach. But also in physics, you can do the equivalent of sampling rectangles. It's like it kind of works for physics. It has that level of abstraction. I think in statistics is a little bit different.
Thank you, Andrew. Thank you.
I think Andy, if you want to ask a question.
Hi, thanks. That's a great talk. So my question is, have you ever come up with a demonstration that you thought, this is going to be fantastic, and it kind of fell flat on its face? And if the answer to that is yes, how did you sort of turn that around to make it into something good? If the answer is no, that's never happened to you, can you talk a bit about how you reflect upon?
Well, I'm always elaborating on the examples, the activities. So the two truths and a lie, like I did it, and then I've only done it once teaching, but I wrote it up, and in writing it up, I kind of cleaned it up a bit. And the candy thing, I've kind of changed a bit over the years in different ways. Yet sometimes things, they don't always work so well. I wanted the book to be done right away, so there are some activities that I wrote up that I've never actually done. We did check that all the code works, but I guess maybe all the code doesn't work either. Just because we checked that it worked, who knows? I think it's in progress. Also, I get bored with things, so there are activities I really liked, and maybe I don't really have a place for them. I think when they don't work, the issue is that they're typically not, the only way they don't work is because they're not closely enough connected to what I want them to learn that week. So the easy way for it not to work is it's just too hard. Like when I talked about this example with the two truths and a lie, I said, have the students come up with a guess of what the logistic regression coefficient is, the coefficients are, and then graph the curve. They can't do that. So I realized I had to step back and have activities in class, which is just, here's a logistic regression coefficient. So I made a new activity. I can't remember if it's in the book or not, but a new thing with a game. And you're in pairs. One of you is in R, and you write A and B, and you have a logistic regression. X goes from 0 to 10, and you specify A and B, and then you graph the line Y is inverse logit of A plus BX. And then you give the person A and B, and the other person who doesn't have R has to sketch it. And then you check your answer. So how do you do that? Well, you figure out where it is at 0, and then you go back and do that. That's a skill, right? So a lot of things I didn't think of as skills. Also, I just thought of them as, people can't do that with linear regression either, right? That's a skill too. So often it's just stepping back like that. But there was a question that you had up there. She had such a strong view, and so I really feel bad if she didn't get to. Thank you.
It's not that good a question.
Oh.
Is that on? So thank you. You mentioned at some point near the beginning that you had two principles you didn't cover.
Oh, that I was violating, yeah.
I was going to guess at one. Can I guess?
Yeah, go.
So, you very masterfully spoke the whole time there, which is, it makes me feel quite envious and inspired. But how do you, I'm guessing in a class that doesn't happen. In a class you want to have a dialogue, or you want to try and bring other people in. And the students are so variable. Often we get certainly a number of students who it's really hard just to come out of the shell, to have the confidence to express their ignorance, I guess, or uncertainty about what they're doing. What are your top tips for really? So
the number one that I do in class I didn't do here is I involve the students. But you see, it's so much easier to talk than to have those. So in the class, if nothing else, when I'm telling stories, I will have pauses built in, right? Like intellectual bathroom breaks, as it were. A story should be 5 minutes long, maybe 10 minutes long, but I would stop. So in the Wikipedia story, both those stories have some visual aids. I don't have slides that go, I definitely don't have slides with bullet points and all that, like this is what we're going to cover today, like that. But I have an image of the Wikipedia thing. Then I have the data. Remember I told you there were too many of one kind and none. So I have the data there, and I say, this is a hard one. I mean, you never say this is going to be easy, right? You know that general thing. You always say it's going to be hard. It is kind of hard, but you never say this. You never say here's an easy one to start off. You'd say here's a challenging one to start off. So here's a challenging one. How could I tell that something was wrong? What did I find? Talk with your neighbor, and they'll notice things. Not necessarily they might notice. They might not, right? So a lot of those. Here's a minute, or the same thing with here's the survey form from Literary Digest. What would you do? Is there any information you could use on this survey? I mean, there's no limit to the amount of hints you can give to people, and they still won't get it, right? So you have to do that. So always, I do that. And no, the shyness. They all talk with their neighbors. Sometimes I wonder whether I should make them change neighbors sometimes. But I will, no, if they're not talking, I will go like this. I'll look at them in the eye and go like this, and they'll realize, or I'll walk up to them and ask them. I walk around their room. My model is like how high school, like in math class, you spend most of your time working on problems. So actually, this was a fun thing. You got to hear stuff. But in class, like it's a feel like working on problems. Like even the story is like, oh, you're watching a mystery movie and you're going to be asked like who's the killer, right? Like they're supposed to be very actively involved. I do like to spend a lot of time having them work together. It takes a bit out of me. Though the second thing that I do in class that I did not do for you was I think it should be better organized. I mean, this was exactly how I planned. I planned it this way, but they should know the structure a little. Now, the first class, I don't start like, my name is Professor Smith, and this is, you're in Statistics 43, and this is what we're going to. No, I start right away. I jump in with a story the first day of class. I actually start with a Wikipedia story with the image and do that. But then I do stop and say, in every class, we're going to do this. This is the story. Now it's time for the class participation activity. Now we're going to discuss. We're going to do a demo. We don't have time for the drill today, like that. So they should kind of know what's coming. And I didn't do that for you just because I thought it would be more fun for you because you're already like, it's a different audience.
I guess that's kind of what my question was a little bit, in that actually a lot of what you did today reminded me of a really great book that I revisited recently, which was about principles of teaching, basically. So I just wondered what your principles were. I mean, you've said two, but I just wondered what your others were.
I don't know. I'm not an expert on teaching, right? Like, so I don't know what principles I have. I think of it as a form of communication. So when I teach communication, I talk about the important things being the goals, knowing your goals and knowing your audience. And goals are tricky because you have many levels of goals, and you have the larger, like your goals of trying to get the job done and do a good job, and then you have the students' goals of why they're taking the class and larger learning goals and so forth. I find it very challenging. I have a lot of stories that make me look bad. Like the first time I ever taught, the first semester as a university lecturer, and it went so badly. At the end of the semester, near the end of the semester, a student gave me a note and said, something like, I actually like this class, blah, blah, blah. P.S. Don't tell any other students I said this. I got the lowest teaching evaluations, I think, in the history of the statistics department of that university. Like, it was like just like, I don't know, the next lower were like people who basically didn't speak English, and I was lower than that. It was really bad. I learned a lot from that. Because I just had, like, I was like, oh, here's a book, but, this book isn't, like a lot of teachers do that, even teaching assistants. Like, oh, here's some extra material for you to read, and here's this and that, and I jumped around the chapter, and I realized you got to teach out of the book. If you're not teaching out of the book, you have to teach out of the equivalent of a book. It's got to be super clear. It wasn't good to have the textbook and not really follow it. You have to commit, right? And that was the beginning of that. And I wasn't really thinking of what they needed to learn, and they said, like, the teaching evaluations were, like the class lurched between being like kindergarten and being like graduate school. And I understand. It's like, oh, here's this interesting stuff, blah, 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 blah. And then they're not understanding. Okay, well, you take X1 plus X2, like, what's that? So there's a lot, I feel like often in statistics, it just depends a lot in the field, but in statistics, there's just a lot of mismatches. So we teach a class, like, oh, this is the statistics class that requires calculus. Here's the intro that doesn't require calculus. It requires pre-calculus, whatever, which is like logs and algebra and all sorts of things. The class that requires calculus, if it's not the proofs class, it doesn't use calculus either, really. The class that doesn't require calculus, they usually don't have algebra. But then you'll have the class and say, well, here, look, we're going to show you something. Okay, the standard deviation goes down like 1 over square root of n. So look, if I take the mean, that's x bar, it's 1 over n times x1 plus x2 plus xn, the expectation of this, well, oh yeah, expectation's like the average. Oh yeah, the expectation is this, blah, blah, blah. Oh yeah, there's this rule that when you add random variables, the expectations add up. Like, you can't prove that, right? That requires calculus, it's hard. Oh yeah, here's that, okay. But then you get this, divide by n, the n's cancel. Look, it's an unbiased thing. Like, what about the variance? Well, the variances add up. Well, if they're independent, well, independence, we can't really tell you what that is. We can't really tell what the variance is either. Oh, and they add up, but we can't prove it. Oh, but here's the derivation. It's like a joke because you're doing this stuff, using stuff they don't know, as if, like, if they knew it, they'd understand all this other stuff. Like, you're speaking in a foreign language, right? That would be like someone trying to teach me, you know, they're trying to speak to me in Spanish, a language I barely speak, right? And they're saying, oh, well, here's a few words you might not know. Oh yeah. I don't know what's going on, right? But then, oh, but don't worry, because none of that's on the final anyway. It's not even in the homework, right? So like you're wasting half your class. People, I don't have time. I don't have time to do these activities because I have so much to teach. Well, maybe you shouldn't be teaching stuff like the sampling distribution of the sample mean, which makes no statistical sense, and you're not testing them on it, and they're not doing homework on it, and you're doing derivations they don't understand. So that's a lot. But let me just conclude before, because I see there's another question, that it's a lot like being a parent, right? You can avoid making all the mistakes your parents make, which is a good thing because you're going to make a lot of mistakes that they didn't make, right? So I found all new ways of being a crappy teacher, but thank God I avoid all the ways of avoiding being crappy because otherwise it would be unbearable, I think. Yeah.
I just want to make a comment on getting people to talk to the neighbors. I use it a lot in my teaching. And on different ways. So sometimes I'd ask them to speak to the neighbor for 30 seconds. Sometimes I ask them to do a small exercise for 2 minutes. But we recently had a workshop on bias, and there we used that speak to your neighbor as well. And it's amazing how much noise you get in the room when you do that, because they have a lot to teach each other. And I think it's really a source that you shouldn't underestimate. But the other thing we did was that halfway through, we randomized them to sit at another table. And again, that worked really, really well. So I think it's about being, be ready to do some experiments. And sometimes it works very well, and sometimes it doesn't.
Yeah, I agree. I like saying things like you're going to get 45 seconds. Partly it's like, it's funny, they're amused, but also like you're conveying that time is valuable in the class, that every 45 seconds counts. I think that's important. The thing you said about randomizing the students, it's interesting because I haven't done that, but I know some people do. It reminds me of the question, which I don't really know the answer to, of how much to open up the fourth wall. Like how much to involve the students in the idea that the class has choices. Because on one hand, I like that. Like I like saying to students, well, this is why we're working in pairs, or this, we're randomizing this. And you're like, when I do an activity, I always like to say what message is being taught. But then if you involve them too much, they can become theater critics. And like that's not like, it's like the US legal system, they say that the jury is just trying to evaluate which lawyer is better, right? Yeah, I think he was guilty, but like I didn't think that they really made the case, you know? Like, what do you mean? If you thought he was guilty, maybe they did make the case, right? Like, but like, So yeah, I think it's very, each time's a challenge. I mean, for me, like I'm off the hook. Like I wrote this book, so I'm giving people tools, and my big thing is wanting people to do more of these things rather than read a whole book and only do one activity. But yeah, my teaching, it's much easier for me to use my teaching as material, as kind of inspiration to create materials. The actual teaching is much harder.
There are a few questions online. Would you choose one or two?
Wait, do you need a thingy to?
I can relay.
Oh.
Yeah. What's the good introductory statistics book that you mentioned but didn't reveal?
Oh yeah, it's by two political scientists. It was Elena Yaudet, Lludet, I believe, and Kosuke Imai. And I blogged about it. You could read my post on it. So if you go to our blog and Google or search for Kosuke Imai, you'll see. He's a political scientist, and he wrote a book like data analysis using R or something like that, like to use as a political science textbook. And then they made it's supposedly a more introductory version. I guess it is, but I actually like it better as a standalone book. You can see my post on it about why I like it. But I like the material that they're teaching. I don't agree with everything they do in the sense it's not necessarily the methods that I would use, but as an introductory book, I like how it's short and it doesn't waste its time on things that are really pointless. And I love regression and other stories, and that's a book we wrote on applied regression and causal inference, but that's not an introductory book.
Maybe wait for the mic, please. Thank you.
Thanks very much for the talk, and particularly the sort of little tasks and things that you could do to break things up a bit. I was thinking in the sense of if you were teaching, when you're in a situation where actually you've already got people who are going to start saying, I've done all that basic statistic stuff, I don't need that, I just want to know which statistical test I do to get it significant, or how many more before P equals 0.05?
Well,
how do you unlearn the things that someone else has taught them?
Well, let me just say that's a completely unrelated question to what I was talking about, in the sense that I'm teaching in class like someone's taking a statistics class. So they've typically taken introductory statistics, and now they're taking applied regression and causal inference. So they would be like, I don't know, they might have questions about how to be a better statistician or how to gather data or how to get statistical significance, but of course they're taking the class, so in the class they're going to learn about applied regression and causal inference. So in that sense, it doesn't come up in that way. That would come up more like if somebody asks me, like someone knocks on my door and says, I would like your help, you're a statistician, I'm working on an important problem, and if I get statistical significance, then my treatment can be approved and we can help the lives of thousands of people. If I don't get statistical significance, it won't get published and people will be miserable. What can you do to help these people? And yeah, then maybe, well, let me say this. Once somebody came into my office and he said, well, could you help me design a study? We're trying to do blah, 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 blah. And I said, I really wish you hadn't said that. And I said, why not? And he said, why not? And I said, because the statistician, this always happens. People come in, you analyze my data, and we always say, if only you'll come to me in the design stage. And I can't say that because you're coming to me in the design stage. Well, it's funny. I was helping some people recently about designing a study, and so the most important things in the design stage are not the things in the statistics textbook. So the most important thing is what you're measuring, what you want to measure, how do you measure it, measurement, taking multiple measurements on each person, like lots of things. Usually the textbook starts with the sample size, like then they have like randomization in the sample size, and that's not so important. So yeah, my answer to you models how I work with people who come in with questions like that, which I don't answer their question. I just tell them a lot of other things that I think are relevant.
Just follow up on that.
Yeah.
What sort of advice would you give, or suggestions would be for those elementary courses that end up teaching people to worry about?
Oh, I would recommend they teach out of the book that I like. I would like to write an active statistic. I mean, our new book is Active Statistics, and that's for applied regression and causal inference. I'd like to have a more basics, called active introductory statistics to have the activities. But if you're teaching such a course, I would prefer to teach out of that book that I like. Again, it's different audiences. Like the undergraduates aren't usually coming in because they want statistical significance. They're usually coming in because they have a statistics requirement. And I don't mean that in a cynical way, like I have to satisfy the requirement. Like I'm in university, I want to get educated. I'm taking a statistics class. I've heard statistics is important. So sure, we should teach them good stuff and not bad stuff. Now the issue of if you're at a medical center and you have a stream of people coming in and they're taking a 4-week unit, I mean, they're taking a 2-hour unit or a 3-hour unit on statistics for medical researchers and they want statistical significance, I don't know what to do there. I think that would be a fun challenge to figure that one out. I mean, people are thinking about that. It's not something I've thought hard about, but it's worth thinking about.
Do we have another question from online? Right,
oh, that's so great.
Yeah.
I never get questions.
So how can we compare teachers in statistics for the imminent impact of AI on the education sector?
Okay, just for the online audience, so how can we prepare teachers of statistics for the imminent impact of AI on the sector?
I guess I don't. You mean like, I think students are going to want to learn how to program AIs, and so that's like statistical, but it's not really. I mean, it's related to the statistics I do, but it's a little different. I think often statistics comes in the evaluation. Like if you wanted to evaluate an AI, if you want to be a student and learn how to do better AI. The relevance of statistics, as we usually teach it, is not so much in the algorithms used to fit the models. It's probably more in the evaluation. Like maybe I'm thinking like a social scientist, but if I was a statistician, the way I am a statistician, the way I could help AI development might be to design a study in which you say, what's your goal? How would you measure the outcomes? Like, it sort of things come back down to that. So in that sense, you can treat the AI as a black box and still think of it statistically in terms of understanding how it works.
I suspect that the poster was asking about things like ChatGPT and students using it to help.
Oh, the question was if students could use AI to do their homework, that they could type in the homework assignment and then do AI and hand it in. And in some sense, you could say, well, it's horrible if the AI does a good job, but if the AI does a bad job, that's not so great either. Then they're handing in bad homework. I think, well, I would say that my grading system will change, and I used to put a lot of grade on the homework, and I put more grade on class participation and on the exams. And you have to do, I don't really like take-home exams anyway so much, but yeah, you can't really be assigning papers for them to write. You can have them write papers or work on stuff in class. I think we should have more class hours. And this is not going to happen at the university because they're having less and less. But I think instead of teaching for 3 hours a week, I would rather teach for 6 hours a week in a class and then have them spend 3 hours less on homework. And we could sit in the room and they could work together. But I mean, the trend seems to be going in the opposite direction, unfortunately. But that's the quick answer is that I think that they would have to do more work in class. Of course, and still, there's nothing stopping people if you know you're going to have a paper to write, of having the AI write the paper ahead of time and then you read it. But that's not that horrible. And if they really have it read ahead of time and they memorize it and then spit something out, at least they've memorized something. They got something out of that. Yeah.
We have time for one more, I think.
But yeah, no take-home exams anymore. Sure.
Right. Okay.
Sorry, if that's okay. I just wondering, do you think mathematics and statistics should be separate disciplines and taught separately in schools and high school?
Oh, I don't know. I don't know enough about high school. Like, what would my opinion mean on a question like that? I guess it's kind of horrible. Like I have a lot of impressions about teaching statistics, and I don't really know much about that, except I know the subject matter, and I've done it a lot. But then the high school, I've thought a lot about how to do better high school statistics teaching. I am thinking that this active statistics book could be a start, that I'm going to work with someone who is involved in statistics education at the high school level and try to create materials. Like, so this could be my entry point into that. But other than that, like, what do I know? I wouldn't add anything by giving you an opinion on that.
Right, okay. Well, we should thank Professor Gelman again. Thank you very much. If you want to think more about statistics teaching, the Royal Statistical Society Conference is in Harrogate in September this year. There will be sessions on statistics teaching, so that is one thing to consider. Thanks to everyone who attended, both online and in the room. If you're in the room, there's the chance to join our drinks reception, which is in the UCL main building in the Wilkins room, South Cloisters. I've been locked out of this PC, but if you don't know how to get there, I will spend a minute to log back in again, and then I will display how to get there for you all. But otherwise, you could also follow the general crowd. Many of you I know are from UCL will know how to get there. So you're very welcome to join. We'll be there for about another hour. So thanks very much.